1,000 kilograms per cubic meter. G is 9.8, H is 1 meter.
So what was it?
For the absolute pressure, you have 9,800 plus atmospheric. So you've got your 9,800, which is your gauge pressure, plus another 1.013 times 10 to the fifth. So that gives you 1.11 times 10 to the fifth pascals. For 4 meters, 39,200 pascals, gauge pressure. Again, rho GH, 1,000 times 9.8 times 4. Then for your absolute pressure, gauge pressure plus atmospheric. So 39,200 plus 1.013 times 10 to the fifth. So you get 1.41 times 10 to the fifth pascals. Absolute pressure adds in atmospheric. Gauge pressure is just the pressure of the fluid. Number 2, you have to watch out for this one because it was seawater. So the density is, according to your chart, 1.0 or 1,030.
I'm dumb.
Okay, I have 1,025.
I can do the seawater density.
So you're dealing again with rho GH because you've got your submarine, and they got your hatch on your submarine, and you've got 50 meters of water on top. Okay? So that represents rho GH, which is 1030 or 1025 or whatever salt water is, times 9.8 times 50. So your pressure, when you get down to here, is 5.02 times 10 to the fifth pascals.
You're not going to live.
And then your force
In this case.
on that hatch is pressure times area gives you force. Pressure is force over area, so pressure times area gives you force. The area for the hatch is 0.5 square meters. Okay, because everything again has to be MKS. So it's got to be 1 times, which is your length, 1 meter, times 0.5, which is your length in centimeters or in meters. So you get this 5.02 times 10 to the fifth times 0.5, which gives you 2.5 times 10 to the fifth newtons. Which is why if you are in a submarine, not that you ever want to, 50 feet down, you can never open the hatch up. Okay? Because there's so much pressure pushing
Just don't
it in.
try it.
As I say, you want to try it anyway. Not 50 meters down.
If you somehow manage to open this thing, you're dead.
Okay, so for the and what you have here is you do have atmospheric pushing down. Okay, but inside your submarine, you also have atmospheric pressure. So the atmospheric pressure inside the submarine cancels out the atmospheric pressure here. So all that you're worried about is the pressure of the water, which is the only thing that's different between the inside and the outside. Inside your submarine, you got people living, so you have to have air, and air is going to be at normal atmospheric pressure. So the atmospheric pressure in here subtracts out the atmospheric pressure here, so you don't have to worry about absolute pressure, you just have to worry about gauge pressure. Unless they tell you to include absolute, okay, because the AP will do this. The AP is big on gauge pressure and absolute pressure. They will ask you specifically, what is the absolute pressure here? Okay, what is the gauge